Welcome to day 2 of the plenary. We've run into some slight technical difficulties with Jeff's presentation, so he's getting his own computer. But as soon as he gets back, we will get started. Today, Jeff Reback is going to lead us off telling us about the current state of pandas. Do you know?
Yeah, no, I have HTML. I have to just, I have to iconify everything here.
So, well, let's see, what can I entertain you all with while Jeff fights with his computer?
Hey, just a second.
Jokes, I don't, jokes.
No, I got it. Oh, actually, I need a display. What do these do?
Does someone have an HDMI to USB-C?
Oh, wait, here. Here.
Oh. Does someone have a HDMI to USB-C? Oh, is it right there?
Right here, sir.
Oh, we found it.
No.
This one.
There you go.
So as a reminder, we're going to have lightning talks again today. The sign-up sheets are upstairs in the atrium by check-in, I believe. If you have anything you'd like to say to us for 5 minutes, please sign up and say it to us. 3 minutes. 3 minutes. If you want to give jokes as well, come to us. And no, if you'd like to give jokes,
it's
please.
Not. Oh no, there it is.
If you'd like to tell jokes, please come sit at these front tables during the lightning talks.
No, it's all right.
And first-timers, please come and underrepresented groups, please talk to Paul or one of us to get you on. And now I can stop talking and Jeff can start talking.
Okay. Oh, actually, let me start my timer because Tom said I have a specific amount of time here. Okay. Hi, I'm Jeff Reback from 2 Sigma. You can see my legal information here. I'm a former quant, and I work at 2 Sigma now. I worked at Anaconda for a little while. And as part of my day-to-day, I work at a hedge fund, so we do modeling, and we use pandas, of course, quite extensively. So we're interested in how things go. So this is Wes McKinney. He is the founder of Pandas about 8 or 9 years ago at AQR, and he gets all the kudos. I get all the complaints. So I assume a lot of folks here actually use Pandas, as noted by the number of downloads on the PyViz. That was very exciting. So just a little history in some sense. This is Jake Vanderplas's slide that he used a couple of years ago here at SciPy. And you can see that the whole SciPy stack is is built very nicely, and it uses each component can use the lower component, and very nice stack here. So Pandas primarily has turned into almost an API. So you use Pandas obviously to do lots of data analysis, data cleaning, but you also use it to dispatch to various things, whereby they be machine learning libraries, or to numerical computing libraries, or to visualization libraries, and we'll talk about that at the very end. So Pandas has almost de facto become a standard for how to hold a data frame in Python, and this is an interesting responsibility. So this is Python has become quite popular in the world, and Pandas has actually become quite popular, or we just have a lot of bugs, not sure which. Fun fact, I started managing Pandas around the 2012 timeline here. Okay, so let's talk about Pandas updating. So what are we doing, and what have we been doing over the last few years? We're modernizing. So one thing we're doing is dropping Python 2. So actually our release 0.20.25 is actually coming out. It's in RC right now. It's coming out any day now. And that we blew away all of our Python 2 code. That was a lot of fun. At the same time, we were actually actively adding typing to almost everything we can. So this actually is a great way to engage new contributors. And it helps find, various bugs that are embedded in Pandas. We have new docs and themes coming up. We've reorganized our docs a lot. This is actually just the reorganization, but not the theme yet. This will be happening soon. We actually have a grant from NumFocus to help with this. And it's always a fun thing to do to enhance the docs. So how do we get to 1.0? And that's the big number everybody wants. The answer is we're going to be releasing 1.0 soon, a couple of months. Our next release, what happened there? So what are we going to include in 1.0? So we've deprecated a whole mess of stuff in 25. And we're going to remove all of these in 1.0. So maybe 60 or 70 deprecations that are slated for removal, including some old favorites. Panel is actually completely gone as of 0.20.5. And IX will be gone as well. So some of you who have not updated code in a while, you will be surprised. But looking toward the future, we are trying to modularize Pandas. Pandas is great because it's a monolith, and it's bad because it's a monolith. If Pandas was built today, it would be built probably in many different sub-packages that everybody could use. But instead of that, we like the idea of the API, and we're going to attempt to allow plugins where appropriate. And I'll show you that in a moment. So one of the big things we've introduced is the concept of an extension array. So these build essentially new D types and new backing stores for these. We've converted, actually here, so here's an existing one. This is actually in 0.20.24.2. It allows the concept of nullable integers. This is actually backed by a NumPy array and a mask array, but as far as a user concerned, you don't care. And you don't even know. We could just change it and it would work the same. So the point here is that we've allowed, we've pushed out a specification of what a 1D array should do and how it should interact with pandas. These become first class in pandas. We've actually converted all of our internal usages, and I'll show you this in a second, to use these extension arrays. So the point is it decouples how we're actually holding the data and how we're interacting with the data. So we can do very interesting things. We can back these by NumPy arrays, multiple NumPy arrays. This is in fact what a categorically is. We can back these by pi-arrow arrays actually, or any other structure that we want to do. So as I mentioned, we've already converted all of our internal types, and we're dog feeding these essentially. So all of these types now they look the same to pandas, and there's no special, well, there's still a little special code, but we're trying to remove the special code and modularize these inside pandas. These were actually motivated by external folks. The first one was this library called CyberPandas. Tom Augsburger wanted to store IP addresses as a first-class citizen. And so this was the original motivation for extension arrays. Since then, a lot of GeoPandas and Pint have come along to support units. And I think in the future, we're going to do many more of these things, including things like a string D type, full-fledged unit support, and actually, there's a project being worked on right now to have full-fledged, when I say JSON here, this is just sort of a test version of this, but full-fledged, in per cell JSON support, which should be very interesting. So I mentioned before, we also want to modularize on how we talk to the world. And so this is another slide that you've seen recently. This is actually the older slide from Jake Vanderplas about what's going on in the plotting ecosystem. So actually in 25, there's a new API. We have decoupled matplotlib. So it is actually walled off in its own corner now. And you will be able to shortly actually interface with other plotting backends. For example, would be Altair or HVplot or Bokeh, merely by using either setting an option or passing an engine keyword. So I think this will go a long ways toward providing some uniformity for basic plotting and allow people to have choice with their backends. Another two things we're considering. For 1.0, we are considering adopting Numba as a required hard dependency. This actually will allow us to have very easy to write code, just as performant, if not more performant for our Python code, and have contributors have a really easy debugging experience. So we're not 100% sold on this yet, but I think it's high probability. We are also considering putting out a hard dependency on pi-arrow for similar reasons, but we'll see. The point is that I think we have the ability now to do this. We love NumPy. but we're not necessarily tied to NumPy completely anymore. And I think this is probably a good thing. So thanks, and that's it. I think I exceeded my time. 2 minutes left. 2 minutes left. Yeah.
Thank you. All right, so now we have Sebastian to tell us about NumPy, and Dask is on deck.
Thank you. I'm here representing NumPy, and I want to give you just a very brief summary of what happened in the last year mostly. So in the past year, we had 2 releases, with the 1.17 release just being a release candidate now and coming out very soon. We have had some nice organizational improvements about having now a better structure around our NumPy enhancement proposals and an improved roadmap for the future. We also have now weekly community meetings, community calls, where everybody is invited to join in, and organized 3 in-person developer meetings at the Berkeley Institute for Data Science. So what are the highlights in the upcoming release that's coming up now? We have had some general performance improvements, and 2 bigger areas are that we now have 2 new sorting algorithms, timsort and radix sort, which means that many types of data or many types of arrays, especially small integer types, are now much faster to sort. We also have now Pocket FFT as a FFT backend, which is generally faster and has improved in precision, and also uses Bluestein's algorithm, which means that those odd-sized arrays are not super slow anymore. A very nice, very exciting new API is that we have a completely new API around random number generation. You can see a short example of it, and this separates somewhat the bit generator from the generator with the actual distribution. It's nice because it's easily extensible for downstream, it's faster, it gives you better bit generators than before, and we have the ability to improve further in the near future. An exciting new feature of the random number generator is also that we now have a seed sequence interface protocol, which means you have a way to reliably and reproducible create nested or spawns of independent random streams. So if you require multiple independent random streams, you should definitely look at this. A big issue the past few years has always been interoperability from NumPy and with different interfaces. So if you write a function f of x as a library author, you use the NumPy API, but really your users might want to use Dask arrays or QPy arrays. And this used to work for many functions such as mean or exp. They had solutions until now. Now we have the array function interface, and Dask and QPy, they are already adopting it. And this means that not just those functions work, but also tensor.dot, concatenate, and most of the NumPy API hopefully will just interoperability work and just work out of the box. So what can you see in the future? We should see some general improvements such as performance. New advanced indexing may appear. A big issue now may be to look at masked arrays based on this interoperability layer that we now have. We can also dogfeed our own and use this for improvements. Improvements in the website and user guide are definitely on the to-do list and about to happen and organized by Ralph Gormas. Another point is to extend our D-type system to make it nicely extensible, which means that we can have unit D-types, categoricals, and a whole bunch of other things. So if you are thinking about this or if you have ideas about this, then I would be very excited to talk to you about this. And with that, thanks you.
Next up, we have James to tell us about Dask.
Hi, excited to talk about Dask. So, slide didn't change. Awesome, there we go. So, for those who don't know, Dask scales the SciPy ecosystem. It does this by exposing interfaces we're familiar with from Numpy, Pandas, Scikit-learn, and scales them to parallel or distributed hardware. There's been a lot of exciting developments the last year, including both a 1.0 and 2.0 release, and I'm just going to highlight some of the changes that have come. So the first one is we have drop support for Python 2 in the 2.0 release. I can hold for applause if needed. Yeah. All right. This has allowed developers to start using Python 3 only features like async IO and using keyword only arguments. And it's also allowed us to start to adopt more modern development practices. There's also been a big push for improved extensibility. So traditionally, a Dask array has been composed of a collection of Numpy arrays and a Dask data frame, a collection of Pandas data frames. Over the last year, there's been lots of improvements, both big and small, to allow us to support other array-like and data frame-like libraries. So, for example, today, you can have a Dask array that is a collection of CuPy arrays that live on the GPU, or, say, sparse arrays. Or you could have a Dask data frame that is composed of a collection of QDF data frames from the Rapids project that live on the GPU. I do want to just point out quickly that there is a CuPy talk, I think tomorrow, and there was already a Rapids tutorial that I recommend checking out. The Rapids group in particular has been sort of invaluable in a lot of these changes. In addition, we've also added support, as was just mentioned, for the Numpy array function protocol. So that allows us to create a Dask array and then pass it off to a Numpy function, in this case, the Numpy sum function, and that will then dispatch the actual execution to the corresponding Dask function. So it'll actually execute the Dask array.sum function and return a Dask array. We've also added support for extension arrays, so using the CyberPandas example. So you can create a IP array for storing IP addresses and MAC addresses, and basically pass that to Dask, and it will just work. So notice the D type here is IP. On the usability side, Dask arrays now have an HTML output. They have an HTML wrapper, so they will print themselves nicely when you're working in a Jupyter notebook. So you get a nice little figure for the array, as well as metadata associated with the array and the chunks that compose the array. Also on the usability side, there have been lots of improvements to Jupyter Lab, and I'm going to go to the community one because I'm going to get kicked off. So the Dask community is growing. We've consolidated our documentation to a single domain. We are now a NumFocus sponsored project, also hold for applause, and we're doing a user survey. So go to dask.org/survey. It's 5 to 10 minutes to complete. We would love your feedback. It'll help us improve the Dask community and help guide future development. Thanks.
So next is Matt Haberlin to tell us about SciPy, and on deck is Xarray.
Okay, so besides a conference, SciPy is also a library that provides fundamental building blocks for modeling and solving scientific problems. SciPy includes algorithms for optimization, interpolation. We've got probability and statistics, fast Fourier transforms, and many other types of problems. We also provide some specialized data structures, such as KD trees and sparse matrices. So you might have seen SciPy being used to produce the first ever images of black hole, M87. We've also been used by the LIGO and Virgo gravitational wave analysis pipeline, and by almost half of all the machine learning projects on GitHub. So in our news, we recently submitted a manuscript about the release of SciPy version 1.0, and we are now a fiscally sponsored project of NumFocus. And thank you. So some new features from our most recent releases. SciPy 1.2 is the last one that is supporting Python 2, and 1.3 recently came out. Well, thank you, I should have held, but that's going to happen a lot, I imagine. So we're on a 6-month release cycle, so these are all in the past year. Interior point is the new method for solving linear programming problems. It's a lot faster and more robust than the old simplex method, and if you still need that precision, the accuracy from the simplex method, we have a new revised simplex method for you. We have a new category of quaternion-based transformations that are available, and we support interpolation of rotations. We have 2 new global optimization methods as well. One is dual annealing, as the other is simplicial homology global optimization, SHGO, for solving those global optimization problems. On the horizon, probably our next release, SciPy 1.4. We have had the Hungarian algorithm implemented in pure Python for solving the linear sum assignment problem for a while, and now we're getting a new C++ version that's a lot faster. Pocket FFT, as with Numpy, is going to be a lot faster version for fast Fourier transforms, and we're adding constraints to our differential evolution global optimization algorithm. And on our roadmap, we want to, that's not working, but we're going to have sparse ND arrays at some point, and the same sort of idea with distributed and GPU arrays. We're not going to natively have them, but we're going to have interfaces for them, as well as continue to evolve the BLAS and LPAC support. As new functionality is added there, we're going to have wrappers for it. So we have a sprint on Saturday and Sunday. Come help us work towards those goals. Thanks.
So now we have Joe Hammond to tell us about Xarray and Scikit-image is on deck.
Great. Hi, everyone. Joe Hammond here. I work on Xarray. I work at the National Center for Atmospheric Research in Boulder. Ryan Abernathy and I are the two Xarray devs here, unless I missed someone else. Yep. OK, so what's Xarray? A bunch of different ways you can describe the Xarray project. Easiest is probably labeled in-dimensional arrays and data sets for Python. It's kind of like Numpy with labels or in-dimensional Pandas. So Pandas doesn't have the panel anymore. Now you have Xarray. If you were using panel, we really hope to see you try out Xarray in its place. It also has a toolkit for expressive data analysis. Mimics the Pandas API when possible. And so I have an example here of an Xarray data set. It's in-dimensional data cubes. The data variables themselves can be different shapes. And then there's indexes along the dimensions. The expressive API allows you to do things like select along the time axis, whereas in Numpy I would have to select using integers. I can actually use a time string. And then I can take the max along the station dimension rather than the second dimension. So this reduces errors and is a lot more clearer for readers. So in the last year, we've kind of hit a stabilization point in the development. Basically no core API changes in Xarray, but a lot of new utilities. So I grabbed 4 that are kind of my favorites. So you can do things that are metadata aware or index aware, like interpolation, grid coarsening, integration, and multidimensional concatenation and combination of data arrays. So organizationally, we published just after SciPy last year our roadmap. These are the kind of main areas that we'll be working on going forward. Boils down to 3 things: more flexible grids and indexing. So this is kind of along the same lines as extension types for our grids and indexes. More flexible arrays in computing. Xarray already supports Numpy and Dask arrays, but we are interested in supporting other array formats. And then more flexible storage backends and making it easier for third-party backends to be plugged in. We are now fiscally sponsored by NumFocus. And then just with my last 30 seconds, thought I would highlight the Pangeo project, which has been working closely with Xarray to improve kind of the scalable science applications in the geoscience space using Xarray, Dask, and Xarray. And there's a website you can check out and a binder that will run a distributed Dask cluster and do some sea level rise analysis. That's it. Thanks.
And our last speaker of this plenary session is Stefan van der Walt telling us about the state of Scikit-image.
Hi, good afternoon, everyone. It's such a privilege to be here and give you a quick update on Scikit-image. Right, so this year we released 0.15 in April. So for the same cheap price, you can now get fewer features when you upgrade, less Python 2, and at least one fewer patented algorithm that slipped in there somehow. So we're Python 3.5 only now. We merged hundreds of PRs in the last release. 75 people committed and 46 people reviewed, but it was overseen by a core team of roughly 5 active core developers. We have our first funded developers now. One received a grant from CZI, so he's one of their imaging fellows. We're very excited about that. And Alex DeZakara has been appointed as a postdoc at BITS, working with me on imaging science. So he can spend half of his time on SciPy, Scikit-image as well. We have a core developer guide now to help guide our core developers in how to review code and do whatever is necessary for the project. And then we grew our core team by 3 developers. New features: n-dimensional flood fill, hierarchical morphological operators. And we built some documentation for the developers themselves, because it turns out if we get new developers in, sometimes they need to learn what's going on underneath the hood as well, and it gets a little bit tricky sometimes. We have a technical and a community roadmap. On the technical roadmap, we're still focusing strongly on supporting n-dimensional support and on standardizing indexing conventions throughout the library. We're working actively on implementing n-dimensional registration and optical flow. Still working to improve speed and to enhance it, potentially looking at things like Numpy and Dask. And we're actively reviewing all our current data sets to remove data that cannot fully be used freely. Our next release is slated for roughly October, which is the 10-year anniversary of Scikit-image. On the community roadmap, we're going to soon have a governance document up. And we'll also be working with NumFocus to get sponsorship there. We have monthly developer meetings for the developers to come together and discuss more complicated issues. We're working this weekend at the sprints on the website, so please come and help us out if you know anything about web development. We certainly don't. And we're actively looking to expand and diversify our core team. Yeah, we'd really welcome you if you would join us at the sprints and work with us. Yeah, that's about it.
So that is the end of the plenary session for today. Can we please thank all of our speakers one more time?